Hey everyone, so we're going to start the next section. It's section 3.4, and we're still chatting about inequalities. Remember, an inequality is when we are comparing two expressions. An inequality has a less than or a greater than, less than or equal to, or greater than or equal to. And today we're going to solve them. We've been solving them. For example, we've solved something like this before, right? Where if it was just one step, this was a one-step inequality, I would just subtract 3 on both sides, and I would get x is less than or equal to 5. We've done this, right? So now we're going to just move into solving multi-step equations. This is a one step, right? One step and we're done. There's some things that we need to chat about before we start to solve multi-step equations, inequalities. So let's jot down some notes here. Inequalities are solved following the same steps as in solving equations. Guys, same thing like this, same thing we've been doing all of our lives, with the exception that you must reverse or flip the inequality symbol when multiplying or dividing by a negative. Again, we learned this last section. We have to remember to flip that sign when we multiply or divide by a negative number. Once we do that, we want to think about, or we have to remember to do that, we're going to first, we might need to distribute or combine like terms. That happens first, okay? Distribute or combine like terms. And then we're going to use inverse operations to get the x by itself or get the variable by itself. Then we want to either add or subtract. That comes next. And then last, we want to multiply or divide. We need to remember this order. Distribute, combine like terms is first. Add or subtract is next. Multiply or divide is last. Some things to note is if we see a fraction, how we get rid of the fraction is by multiplying the inequality by the denominator. Again, we kind of did this in the last section. If you saw something like this, if we saw a fraction, we would get rid of this fraction by multiplying both sides by that denominator. So this is very familiar. Okay, these two are new. Sometimes when we solve, the inequality will end in a true statement. Sometimes it's going to look like this. The variable disappears for some reason. And when the variable disappears, there's two things that can happen. The inequality is going to be left to be true, or the inequality is going to be left to be false. If it's true, like for example, this is a true statement. 2 is less than 5. That's true. My answer is all real numbers, because any x value would make this inequality true. If when we solve, we get a false statement, for example, this, 5 is less than 2, we know that's a false statement, then there are no solutions. If it's false, it's never possible. Okay, so let's go through some examples here. Okay, first thing, we're going to, there's no distributing, no combine like terms, adding or subtracting. I'm going to subtract the 4. We use inverse operations. I get 7b is greater than or equal to 7. And now I need to get this b by itself. I either multiply or divide. Currently this is multiplication. I undo multiplication by dividing. And I get b is greater than or equal to 1. The next one, add no distributing or combining like terms, but I will subtract first. I'm going to subtract this 1. Because I need to get this m by itself, I need to move the 1 first, and then I'll be left with negative m over 3 is less than 5. Here's that fraction we were chatting about. If I multiply both sides by that denominator, and I'm going to take that negative with it, then the fraction will be gone, and I'll be left with m is less than negative 15. But remember what we just did. We just multiplied by a negative. So what happens when we multiply by a negative? We have to flip that sign. Remember that. No distributing or combining like terms. I'll start by adding and subtracting. So undo addition by subtracting. Here's that fraction again. I'm going to continue doing the same method we've been doing. To get rid of the fraction, we multiply by the denominator. When I do that, I'll be left with 2x is greater than 15. And then do division here to get rid of that 2. And we can leave it just like that. A couple more. Notice now I've got some distributing that can happen. So I'm going to distribute the 6. And now we'll continue like normal. I'm going to subtract the 12. And I'll divide to get that x by itself. I see a fraction, hate the fractions, right? Let's get rid of the fractions. 6 is canceled and we're left with the numerator. And now I solve this like normal. Divide by -3. Remember, when I divide by a negative, we flip that sign. And then another one here, I see that fraction, hate the fraction, multiply by the denominator to get rid of the fraction. Notice now I've got some distributing that we can do. Remember, distribute, bring the 5, multiply the 5 to everything inside the parentheses. Solve for the n. Next, we're going to do any addition or subtraction. And then get this n by itself by dividing both sides by 5. Remember, here's a fine answer, or we are used to seeing the variable on the left, so we just flip everything around, including the inequality. These are the same. Let's check out the special cases now. So we're going to continue this like normal. I see some distributing that needs to happen, so I'm going to distribute this negative to everything inside the parentheses. And then I'm going to combine like terms. So I'm going to combine these x's. Notice when we combine the x's, they go away. And I'm left with -6 is less than -7.5. And I want to think about, is that a true statement? Is -6 less than -7.5? No, right? This is false. So because that's false, our answer is no solution. So when the variables disappear, don't be scared. That's a possibility. Sometimes the variables are going to go away. Think about this inequality that's left over and just figure out if is it true or is it false. Let's check out this one. I'll distribute the 5 first because I know to do that because of the parentheses. Combine like terms. We'll combine our variables. Notice when I combine the variables disappear. And I'm left with this statement. And I want to figure out, is that a true statement or a false statement? 20 is less than or equal to 20. Well, that's true. So my answer is all real numbers. X could be, or W could be any real number. Okay. So let's just check out some word problems here. This first word problem says, an animal shelter has fixed weekly expenses of $750. So that's a flat fee. Every week, that's how much they spend. Each animal in the shelter costs an additional $6 per week. So that's how many animals there are going to each cost $6 per week. During the summer months, the weekly expenses are at least, this is really important, at least $1,170. Write an inequality and solve the inequality that represents the number of animals at the shelter. So right away, I remember each animal is $6 a week. So I'll have 6 times A, if we want to say that A is the number of animals in the shelter. 6 times A plus the flat fee of $750. At least, we have to get this in terms of an inequality, a less than or greater than. Think about at least $1,170. Is that less than? Does that mean less than $1,170 or greater than if it's at least? That means it's going to be greater than $1,170. Here's our answer to the inequality, and then we've got to solve. So I'll subtract 750 from both sides. Divide by 6. And we get A has to be greater than or equal to 70. So what that means is that there are at least, so use that same phrase, 70 animals at the shelter. Okay, and let's check out one more. You need a mean score, so we're talking about average, of at least, here's that at least 90. Guys, as soon as I read that, honestly, I'm just going to go at least is greater than or equal to 90 to advance to the next round of the trivia game. If your first 4 games had a score of 95, we're doing mean, so I know we're going to add these all together. Remember, mean is add them up divided by how many? What is our 5th score? So I put an X. Needs to be to get at least a 90%. And there's our equation. Mean, you have to remember what mean means. Mean is the sum of all of the items divided by how many are in the set. So there's 1, 2, 3, 4, 5 scores, and I need to figure out what that 5th one's going to be. And then we'll solve this. Multiply both sides by that denominator to get rid of the fraction. When I do this, I'm going to add these up, and I get 352 plus x equals, multiply both sides by 5, that's going to be 450. Oh, and it's not equals. It's greater than or equal to. And then solve that like normal. We get x is greater than or equal to 98. So what that means is you have to score at least 98 to move on. Okay, so guys, this is the first lesson on solving multi-step inequalities and some word problems. Great job. Thanks for taking notes.